Hi, Ruben here from Muller Energy. Today I want to talk to you about our new 6S to 22S BMS. It's a 320 amp BMS, however we've derated it to 250 just to make sure that it stays nice and cool and it can do your 250 amp continuous. I said it's a 6S to 22S BMS, however we're using it mainly as an 8S BMS or a 16S BMS, depending on which balancer you get with it. So the balancer will basically set it to either 8S, 24 volts, or 16S, 48 volts. I will mainly be filming this instructional video with the larger balancer, the 16S or 48 volts, but it's almost identical for the 8S, and I'll mention how to install this as well. So when you receive the kit, you obviously have your BMS with some cables attached, but you also have some other cables that come with it as well. So you've got two cables that look very similar here. However, one has 9 cables and the other has 8 cables. If you're getting the 8S system, you'll only get the 9-pin connector, not the 8-pin one. So we will start with that. Actually, first, what we need to do, the first step is take a power cable and connect it to the BMS. So here it says B-. We will be connecting the power cable to the B-. You can use either one of the connectors or both of them to screw something to. I'll just be using one. And given that this is a demonstration only, I'll only be doing things hand tight, but obviously you would tighten it a lot more than that. In general, I would recommend sort of between 4 and 6 Newton meters. If you don't have a torque wrench or anything like that, just get yourself a regular one. I've insulated this one with electrical tape because if you drop them onto your studs, it can create some sparks otherwise. Never happened, but let's not have it happen today either. So I've connected the cable to the B-. Then the next step would be to connect this to my main negative terminal. So I've set it up in an alternating fashion, as you can see. Negative is this gray one here, and unfortunately the positive one is black. But the way I've set it up is your main negative is here, then it goes to that cell and so forth, and you end up at the main positive down here. You'll see that in a second when I connect the bus bars to it. By the way, if I was building a real battery, I would certainly use epoxy sheets to go between the cells. The reason for that is that the case is aluminium, it's connected to one of the terminals. So if you have, say, a small piece of metal caught between the two cells, it will rub and go through this thin film eventually, and then you'll have a dead short on your hands, and obviously we don't want that. So yeah, we'd have it done like that, and obviously have another few down here as well. But today we won't be worrying about that too much. And so this is our 9-pin cable. We'll take the black. It's important that you put the higher the current, the closer it's got to go to the cell. So we'll take the power cable first, put that on here, and then put the ring terminal on there. Now normally you use washers for everything I do to distribute the force better, but because I'm only doing this for demonstration purposes, I won't bother with that. Now, as I was saying, you do screws tightly if you were doing it, and I'm just going to do them hand tight. However, here, this one, you would only do sort of hand tight as well. The reason for that is this is coming off again, and I'll talk about that a bit more in a second. So now we've got our first balance wire connected. You can see it goes black, blue, green, yellow, white, blue, green, yellow, red. It's very important that you do those in order. I like to just hold the connector like that and then just go one by one as I go through them. if you get them wrong, you could damage the balancer or the BMS or both. But yeah, hopefully that won't be an issue. So yeah, I'll go with the blue wire and connect that on there. So what I've got to do first is take a bus bar and connect these cells together. Now for this video, will be connecting them all to the positive terminal of this battery rather than the negative of this one. It really doesn't matter which one you do, because they're connected with a bus bar, they're at the same voltage potential, so you can use either of them. You can even swap it around as you move on, depending on how your cable runs are better. So yeah, as I said, I'll put that on the positive, and I will then put the nuts on. Now, I will speed this part of the video up, just because there's not much benefit of seeing it in real time. So I will see you again in a second. Okay, welcome back. We're just placing the last ring terminal, the red. Now, if you were building an 8S battery, this is where you'd finish. So this would be your main positive terminal. Obviously, you wouldn't have any of these cells here. And yeah, you'd be connecting your positive power cable to this. But as we're doing a 16S, we'll just do the same again. So you've finished with red, and then here you'll go black again on that cable there. So again, I'll speed it up and see you soon. Okay, now we're just doing the final wire. As I was saying, that if you were building a real battery, you'd put your power cable on now, then put this on. And as I said, for the main negative, we'll only do it finger tight for now. That's because we've got another connector to go onto. So we will actually connect that up now. So we've got this cable as well. The way you'd normally use it is that you'd have it in the side wall of the battery, and you'd only have this part protruding through it. And you can then take the touch screen and plug that in there, and this is the communication to the BMS. But because we don't have a battery case here, we'll just connect it all up. So basically we'll take the red end and put that on the positive, and then we will take the black end, undo this nut again, and put it on top of here. And as I said, I like to always stack them from high current carrying to low current carrying. So the bottom one might carry, well, obviously this is too small for 250 amp, but it could carry up to 250 amp in theory. The balance wire, because it's a 5 amp active balancer, could be up to 5 amps. So that's in the middle. And then the top one, the screen really isn't going to be using much current at all. So that's all connected up now. What we have to do next is actually connect the balancer and then the BMS. Now, it is very important that you follow this order that I'll show you now. The reason for that is if you don't, you're not going to break anything, so don't worry about that. But if you don't, you're not going to have your BMS set to 16S or 8S. So the order is you take the 9-pin connector first and you connect it on the BMS. Sometimes there can be a few sparks. These are capacitors, meaning there can be a higher inrush current. Because mine are pre-charged from connecting them earlier, there wasn't a spark. But as I said, if there is, don't worry too much about it. There was a small spark there, but that's all okay. So this one goes on second, so 9-pin, then 8-pin here. And then you can see on the BMS, it says BC0. So this is basically the lowest potential to the highest potential. We will take the large connector from the BMS and plug that in first. And then after we've done that, we will take the smaller connector and plug that in. So now effectively both your balancer and your BMS are connected. Your balancer isn't going to work yet. The reason for that is it actually requires a signal from the BMS to be plugged in for it to work. So that's what this little blue and white wire is. So we'll put that in here. And now this balancer will turn on whenever the active balancer, the passive balancer on the BMS is active. This active balancer will run. Now, another thing we need to do is to connect the other end of this cable. Right now it's floating in the air. So we will take it and we will connect it. Sorry, I know it's a little bit difficult to see, but we'll connect it to the RS485 connector here, which is a serial communication protocol. So that is now connected. Now that we have connected that cable, we've got 2 more cables to connect. One of them being optional. The first one is Bluetooth, and while strictly speaking that is optional too, it comes with a kit and it's really recommended you use it. Just makes it a bit easier at times to change some settings. The other one is a discharge switch. Now, we can plug that in where it says discharge switch on the BMS, and it means that the BMS will only be able to discharge when these 2 wires are connected. This is the default out of the box. I actually recommend you get rid of this cable because there's an override. And while it's great to have a BMS with a disable, we do have another way of doing that. So if we connect the screen here, first you see the state of charge, then the current, voltage, temperature, and time to empty, time to full. Time to empty or time to full is only accurate if you're drawing a current of a few amps or more. And then here you can see we've got an estimate of amp hours remaining. Now this is, I haven't set the capacity, so this is wrong, but you've got it on there anyway. You can see here it says DSG. DSG is discharge. Now, if I turn this off, it's now off. I've got the same function as I would have had with a discharge switch, but it's just a lot easier. You can do it on the display. You can do it in the Bluetooth app as well. And now if I've got this in a battery box and I've got my terminals on there and I accidentally short the terminals, nothing's going to happen. I highly recommend you turn this off while connecting something or working on the electrical system, or even if you have an inverter and you connect that, you'll have inrush current similar to what we had with the balancer here, obviously on a much larger scale. So if you don't want any sparking, turn it off while connecting the inverter. Once connected, turn it back on. And yeah, that's the main settings here. On screen 3, you can see all the cell voltages, and this one isn't in balance just because it's a bit of a prototype setup, but normally, yeah, you'd want it in balance. So yeah, here it's not horrible. We've got 16 millivolts difference, but normally you'd want it to be sort of 5 or less. This is nearly it. So one other thing we have is NTCs, or temperature sensors. These make sure that the BMS turns off if the cells get too hot or too cold. Now you can see there's not 16 of them, there's 2 of them. So what I like to do is connect one here. So you've got 4 cells there, 4 cells there, and then you connect one here. So again, it's never more than 4 cells away. You can use Kapton tape to connect them, or you can use silicon. I tend to use silicon and then put a bit of tape over the top while it cures. You can also go top or side, it doesn't matter. There's another temperature sensor within the BMS as well, so it will make sure that nothing overheats. I will now disconnect the 16S and connect the 8S balancer to show you that it's very, very simple. So first I take this wire out. Then these can be a bit hard to undo sometimes. Make sure you push the little clip down properly. And sometimes you have to wiggle them sort of side to side as well. Now, as I was saying, for the 8S balancer, you only use the 9-pin cable, or 9-pin connector with 9 cables. I'll plug that in. As I mentioned before, for the 16S, it's very important that you plug in the colorful cable first, and then next you take the larger of the 2 cables going to the BMS, and then the smaller one. And finally, we're connecting this little wire, allowing the balancer to run. Now we've already switched modes. You can see it's 15%, 26 volts. And if we go to the individual cell voltages, you can see there's now only 6 volts. So as I mentioned before, this would become your main positive. You'd put your temperature probes sort of here and here. And that's basically it. If you have any questions or comments, we'd love to hear from you. You can either leave a comment on this video, or you can email us on support@mullerenergy.com.au. This BMS is also available for purchase, both as the 16S and the 8S version, the difference only being the balancer, of course. And you can also buy it in a kit, both with 105 amp hour cells like I've got here, or with 314 amp hour cells. Just to give you some reference, this will be a little over 5 kilowatt hours, while the larger cells will be a bit over 15, sort of 16 kilowatt hours. All right, I hope you enjoyed this video, and I'll see you next time. Thank you.